Welcome to The Life of Her Mind, a Lab Roots podcast devoted to learning how women think about their research, their fields, and their future. My name is Mia Wood. I'm delighted to have the opportunity to interview Dr. Katherine Roe, a chief scientist within the Laboratory Investigations Department of People for the Ethical Treatment of Animals. Dr. Roe earned bachelor's degrees in biology and psychology from Syracuse University. She went on to complete a PhD in psychology and cognitive science from the University of California, San Diego, before completing a postdoctoral fellow at Johns Hopkins University. Dr. Roe then served as a research fellow at the National Institute of Mental Health for 8 years. Among Dr. Roe's research areas are the neural correlates of language, spatial, and memory processes. Dr. Roe has also worked with children with early focal brain injury, both adults and children with schizophrenia, and individuals with Williams syndrome and related genetic disorders. Dr. Roe's extensive experience conducting brain and neuroimaging research with humans and expertise at experimental design and data analysis has shaped her current work. Last but not least, Dr. Roe's findings have been published in numerous peer-reviewed journals and presented at numerous national and international industry conferences. Dr. Roe, welcome and thank you for making time to chat.
No, thank you for having me. I'm thrilled to be here. Thank you so much.
Well, let's start with your story, your origin story. How did you decide to become a scientist?
For me, it was the short answer is slowly. As a young, during I'm not from an academic family. My parents didn't go to college. There weren't any scientists or biomedical professionals in our family or in our inner circle. We didn't even have family friends who were scientists. And I think growing up, I always thought to be a scientist meant you had to work in a wet lab. We were talking about goggles and pipettes and Bunsen burners and chemicals, and that I knew wasn't for me. And it wasn't really until I started college and started taking classes in biology and psychology and linguistics and started learning about the brain and how the brain and human behavior intersect. And suddenly I was hooked, like hooked. I was engaged in in those sorts of topics in a way that I probably had never been for anything in my entire life. And even more so, I had my own questions. It wasn't just, well, this is really interesting to learn about, but what about this? What about that? Do we know this? Do we know that? And, over the course of my undergraduate career and really just taking basic coursework, I started to realize how interested I was in the human brain and in human behavior. And that answering the questions that I had could be a job. I mean, that was like the most amazing thing. Who knew that you could have a job where answering your most pressing questions was the job, that you could get paid for that and spend every day working towards answering really, questions that were interesting to you and that might even help other people. So I went from being a mediocre science student. I did not do well in science classes in high school to being all in. And that was because my definition of what a scientist was expanded beyond what I think most people, I think most people, when you hear scientist, you actually picture somebody in a clinical setting or, wearing a lab coat and goggles, and they've got a beaker and a pipette. And that is, and that's great. That is for a lot of people how they engage in their scientific endeavors, but it's not all there is. There are lots of questions that need to be answered using lots of methods, and they don't all, require working somewhere with an iWatch. And so for me, that was eye-opening, and a dream come true, really, that a job could be something you love.
Right, as opposed to work because you have to.
Yeah.
Do you, looking at the time or looking back, do you have some idea about what it is about that sort of standard model of what it is to be a scientist did not appeal to you, and then what it was to think about brain stuff very generally, that captured your attention.
Yeah. I think because in junior high and in high school, when you're taking, your first introduction to science, it's a lot of measurements, and all this is important. Like the
Mhm,
foundation of science is the same regardless of what you end up pursuing.
mhm,
But I think you don't talk about in your seventh grade science class, or even your high school science class, the impact of a brain injury on somebody's behavior. You don't learn about what aphasia is, or what prosopagnosia is, or the fact that, certain parts of your brain are critical. That it's just not part of that early discussion. The early discussion is on paper, and then if you're doing any kind of experiments, they're really basic.
mm,
And
mm,
so I think that, again, it could have just been a lack of pursuing bigger questions when I was in junior high. But to me, it didn't look interesting. I didn't want to work with chemicals. I didn't want to, Bunsen, like just the smell of chemicals alone is not appealing to me, and the questions that they were answering about, like, a chemical reaction
mm,
was interesting on a piece of paper,
mhm,
but I didn't want to do it. It wasn't something, let somebody else do that. That's somebody else's passion. That's somebody
mhm,
else's job. What I didn't know was that there were so many other
mhm,
scientific pursuits out there, and that one of them, if not more than one of them, suited me to a T. And
mhm,
and again, when I was taking, introduction to psychology, I mean,
mhm,
like Psych 101, as you would call it, and learning that how the brain influences behavior, and learning about, even very, very unusual patient populations, people with people who like HM, who was a famous patient who had memory deficits after a certain part of, this was brand new to me,
mhm,
and completely fascinating. And as I took more and more advanced classes, it didn't stop. It
mm,
it only enhanced. The more I knew, the more I wanted to know, and
mhm,
that is something that was new to me. Just the idea that there was I wanted as much information as possible about a certain topic, and even more that I had questions about a certain topic that hadn't been answered yet.
mm,
That even the professors at the time were like, "That's a good question. We
mm,
don't know the answer to that, but that would be a really good thing to pursue."
mm.
Me?
Yeah.
You mean me? Like, I could be a scientist? That's what a scientist is
Okay.
somebody who answers questions not about chemicals, but about the human brain, or I didn't, it really expanded my view of what science was, and that it included me, and that it included the sort of things I wanted to do. And it was great. I mean, really.
Do you so one of as you were talking about this sort of emerging awareness
Mhm.
about what you could do, I was thinking also about the compared to other bodies of knowledge, how nascent, if you will, brain science or
Yes.
cognitive science is. So, and then also, I'm thinking about the amazing program at UCSD, the
Yes.
interdisciplinary cognitive science. I mean, wow, there's just really cool stuff going on there. So, in fact, a colleague and even students I've had who are interested in psychology or in my discipline, philosophy of mind, I say, oh, well, UCSD, here are these interdisciplinary connections. Like a colleague of mine who thinks about, Aristotle on time, she would go trotting over to some cognitive scientists in the UCSD program and say, well, hey, how are we, what are you guys saying about the brain and time and that sort of thing?
Mhm.
But anyway, so you end up in what I'm thinking of compared to other sciences as like a nascent
Mhm.
um, endeavor for in a number of areas, including how much now we are able to map and observe without being invasive, right? So,
Mhm.
how did you end up focusing on non-invasive ways to image and analyze the brain, and what sorts of questions became the most interesting to you?
Yeah, yeah. No, I think you're right. I think when I was in undergraduate many, 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 many moons ago, neuroscience was new as a field that you could study. And in fact, where I did my undergraduate work, which was at Syracuse University, it was only in my senior year that they offered a neuroscience class, and it was the
Oh,
first one.
wow.
So the field, studying the brain specifically as a career, as a field of study was itself new. And as you said, we still don't know how the brain works. So there's certainly, an infinite number of questions about it that a young person like me could pursue.
Mhm.
I was captivated by um, language acquisition.
Mhm.
I still am. I say it like it was a past passion. It's not a past passion. How humans develop language is amazing to me.
Mhm.
It's just, as far as I'm concerned, and I'm sure people will disagree, as far as I'm concerned, it's just the most phenomenal thing. It's the most phenomenal thing. It's phenomenal to watch. You don't even have to study it. Any parent or anybody who works with children from a very young age until they're about 3 or 4, the progress is astounding. And so I think it helps when you're studying, when you're interested in a human specific behavior. And not that of course, other animals have communication systems, but I was interested in human language.
Mhm.
So I wanted to study human language and how the brain mediates human language development. So that sort of necessarily already puts me into a very human specific area. And I was so blessed. I mean, so blessed to get into the UCSD graduate school program and work with the most amazing developmental neuroscientists available, and that includes Elizabeth Bates, who was she's passed on, but she was a force to be reckoned with when it came to understanding human language. And I got to work with her. And a woman named Joan Stiles, who, was a brain development expert. And both of those women were working with children with early focal brain injury
Mhm.
and looking to see how that early brain injury shaped development of spatial processing and development of language processing. And I got to join that team
Mm.
while I was getting my PhD. Again, as an undergraduate, I thought, wouldn't that be amazing if I got to go and work with these people who are writing these papers about this topic that I'm so passionate about? I did. I got to do it, and in San Diego to boot. With the weather is amazing. The whole academic atmosphere is
Mhm.
amazing, and people, the labs I worked in were phenomenal and happened to be non-invasive.
Mhm.
I think, and this may come up when we talk about what I do now,
Mhm. Mhm.
I think if somebody had told me when I was 18, 19, I was in grad school at 21, because, I
Mhm.
was still a child, really, in a lot of ways, hadn't experienced much in life. If you had said to me, well, the questions that you need to be answered should involve experiments on animals, I probably would have done it.
Mhm.
Now it's something that I'm opposed to. But when I was 21 and trying to pursue a career in science and trying to answer questions with the tools that were available to me, which as a grad student is the tools that are available to the people you work with.
Mhm. Mhm.
Um, you don't have a lab when you're 21. You get the opportunity to work in a laboratory,
Mhm.
and
Mhm.
you use the tools that laboratory is using, and you take the training that you have access to.
Mhm.
So if you had said to me then, well, your questions about the brain would be best answered using monkeys, or
Mhm.
I think I probably would have gone ahead and done it. So for me, the fact that I did focus on non-invasive human-based research was a little bit of luck.
Mhm. Mhm.
I'm grateful for it now, but I certainly wouldn't want to portray that I had some ethical awareness when I was 22 years old that I didn't want to experiment on animals. I was never asked to.
And what was culture's the wrong word, but what was it about the work that, for example, the two scientists you mentioned
Mhm.
were doing that didn't lead them in the direction of saying, for example, okay, well, we could scan, a monkey brain. We just need to anesthetize the monkey, and then we can make a comparison between, or whatever, however it is that the procedure works. Like, what, why didn't they? Do you know in retrospect or at the time why that wasn't part of their lab work?
I think because they didn't have to, because they
Okay.
had the questions they wanted to ask, which was how does human cognition develop, whether it's language or space or memory, um, in a neurotypical situation,
Mhm.
and how does it develop in a neurodivergent situation? The term neurodivergent was
Yeah.
not available back
Right.
then, but that
Right.
is
Right.
that is the term we would use now.
Mhm.
And they found a way to do it. There was a lot of the understanding. Again, things have changed, but early on, a lot of how we understood how the human brain work came from adults who had had a stroke or had
Mhm.
had some sort of traumatic brain injury, and then the symptomology that happened after that. So this person had this part of their brain damaged, and now they're struggling with language, or they're struggling with their memory, or they're struggling with their spatial navigational skills. So if you're interested in development and how different cognitive capacities come online and how brain changes early on affect that, are there children with
Mm, mhm.
early brain injuries? And there are, and that's how that was the path they chose. Do I know what those individuals felt about animal experiments? I don't.
Mm,
It was
mhm.
never discussed. It was
Mm.
honestly a topic that didn't come up for all 30 years that I was doing research, and that's the truth.
Interesting. Okay. So a follow-up question there, it would be, I think, well, one among many. So I'm really curious about your fascination with language acquisition. I'm curious about, for example, the what sort of connection, if any, there is between the thinking prior to language acquisition. Like, we're so used to, as adults or even as younger individuals, conceiving as opposed thinking in concepts,
Mhm.
which would seem to require language, as opposed to having some sort of brain activity that doesn't require language, but there's still but thinking is still happening there. So that's one, like, kind of what excites you about that. But then another question, which would lead us more in the direction of where you're working now, is, um, if we set aside questions about what we should or shouldn't, ought or oughtn't to do with each other and with other living creatures,
Mhm.
um, what sorts of um, what sorts of questions and experimental processes would seem to necessitate the use of non-human animals? Because you said it just never came up in your training at, one of the most prestigious institutions for neuroscientific activity.
Mhm.
Sorry, scholarly activity. Right.
Yeah.
So I don't know if there's a preference that you have for which way you would like to go. Either uh, I hope we'll get to
Okay.
all of it, but
Yeah.
either, the excitement of language. Why was
Mm.
that so interesting to you? And sort of thinking independently of language, if that's even doable
Mm.
in a way that makes sense. And
Those
then,
are deep philosophical questions, if I can't think in a language form, can I think at all?
yeah,
But,
yeah. Yeah.
for me, it was never those deep philosophical questions about the ties between language and consciousness, though for a lot of people it is. For a lot of people that is a pursuit,
Mm,
that they're very passionate about.
mm,
For
mhm.
me, it was almost the procedure. How do you go from
Oh,
having an infant who
yeah.
can't speak at all to a one-year-old who can now say at least mama and dada and
Mhm.
more and no and maybe hi and bye, to a two-year-old who can now communicate that they want mommy to give them more cookies,
Mm,
and that they don't, and they want to, go outside, to a three-year-old who can basically communicate as well as, and maybe not with the same vocabulary
mm,
level or the same complex syntax, but can communicate very effectively.
Mm.
You know, I don't speak a second language. It would take me way longer to learn a second language than it takes an
Mhm.
infant, and so so many people had pursued this question, so there were just these phenomena out there already, about how this happens, and yet so many questions about how it happens. So for me, I think, just the phenomena that is language acquisition
Mm.
is interesting enough. Um, and typical language development. I wasn't even as interested as some people are in atypical language development. I was just amazed at how children go about this,
Mm.
and what the changes in the brain are at different stages
Mm.
early on, that facilitate this. Um, are there cognitive precursors? I mean, in the field
Mm.
of language, there's a lot of ongoing debates. How much is there a language gene? Is there a grammar gene? Are we
Mm.
built? Do humans come to this earth with all of the properties they need for language acquisition? How important is input?
Mhm.
How different are our communication systems? I mean, there's infinite questions about language, and I am interested in hearing about all of them and participating and answering them, and that for me was amazing. And your second, I guess the other question you were asking is how can it be that it didn't come up? How can the use of animals not
Mm.
have
Mhm.
come up? And so I want to clarify.
Yeah.
Um, I certainly heard about animal
Mhm.
experimentation and research with animals while from the beginning,
Mhm.
from the first psychology textbook that I opened. It just wasn't an active part of my life. It
Mhm.
wasn't something that any of us were doing, and it isn't something that I knew a lot about. It
Mhm.
wasn't something that came up as an ethical discussion, which is
Mhm.
interesting, right? Like you'd think if you spend 20 plus years studying the human brain, a lot of information that we have about brains comes from non-human brains, and it's in your coursework and it's in the seminars that you go to. Yes, of course.
Mhm.
Um, I think because all you hear about in that context, what makes the textbooks, what makes the webinars, what the quote unquote famous animal experiments
Mhm.
or
Mhm.
seminal animal experiments are the ones that worked.
Mhm.
One.
Mhm.
And two, you don't hear about the procedures. You
Mhm.
don't see the procedures.
Mhm.
What is in the textbooks about Harry Harlow? What is in the textbooks about Hubel and Wiesel? What is in the textbooks about Pavlov? These are seminal studies with animals that any introductory psychology class is going to cover. Don't get into the harm so much.
Mhm.
The imagery is lacking. It's not detailed. It's rarely a picture of one of Pavlov's dogs with apparatus
Mhm.
secured to their salivary glands and
Mhm.
restraints.
Mhm.
Most people know about Harry Harlow's cloth versus wire monkey study, right? And it's an attachment study where baby monkeys were taken away from their mothers,
Mhm.
and he observed whether the motherless monkeys preferred a cloth comforting mother monkey or a wire monkey that had a food source, as
Mhm.
a way to study what drives the bond between a mother and child. Is it that she
Mhm.
provides nutrition or that she
Mhm.
provides something more?
Mhm.
It's a famous study.
Mhm.
If you take a psychology class, you'll hear about it. They don't get into the fact that some monkeys in that lab were put into what is called the pit of despair,
Mhm.
where they are deprived of all sensory information and
Mhm.
come out psychotic. They don't talk
Mhm.
about the rape rack they used to
Mhm.
get in mothers impregnated because the mothers had been so damaged from the earlier experiments. They don't talk about the mothers who killed the babies because they had been so damaged.
Mm.
That's important,
Mhm.
I think, when thinking about animals in experiments is the harm, and that gets it in the average textbook when they talk about animal experiments, they talk about the success. Like we found
Mhm.
this really important piece of information that is now, you know, driving other research and not the harm. Or
Mhm.
you hear about the success story. Well, this experiment worked and we got a piece of information about whatever it's about, whether it's about cancer or it's about genetics or it's about the brain or it's about the heart, and not all the failures, not all the harmful experiments that came into nothing. And so it's just not discussed. So I don't want to suggest that as a neuroscientist, I didn't hear about animal experiments, because that would be a lie. Of course I did.
Right.
I was hearing about research from animals all the time,
Mhm.
just wasn't engaged in it directly.
Mhm.
And it was never a discussion in terms of ethics. Like, is it okay to sew the eyelids of kittens shut to see how visual input affects visual cortex development? It wasn't discussed.
Mhm.
It was sort of a given, at least in my experience, it
Mhm.
was a given that if it was done in the pursuit of scientific knowledge, it was justified.
Mhm.
And I just assumed that was true,
Mhm.
because that was how it was presented to me, and I didn't question it. Why would I question what a bunch of people that I respect,
Mhm.
who all have the same questions I do, who are all working hard and trying to answer a question the best way they know how, why
Mhm.
would I ever doubt that
Mhm.
it was something I did or didn't agree with? And so I didn't. I mean, I
Mhm.
honestly, because I was studying humans, most of the research I read about was even human based, and
Mhm.
the animal experiments that I learned about were only the ones that had value, and
Mhm.
the harms associated with them were minimized, if not absent, from those discussions. So,
So how did you come to oppose um, the use of non-human animals in experimentation and or other testing, for example, product testing, right?
mhm,
Um, yeah, how did that come about for you, particularly given that you didn't, yeah, you hear about it and you make this really important point that it it the implied position is the end justifies the means.
mhm,
But then when you're looking at the means, you think, wait a minute, hang on, there's a lot of harm here. That's problematic. Right. So
mhm.
how did you that wasn't a part of your world. So how did that
Yep.
happen for you to say, wait a minute, no, this is not what we should be doing?
Yeah, it was, again, it was slow.
Mhm.
It was information based. It was evidence based. So,
Mhm.
it wasn't something I questioned while I was at UCSD or at Johns Hopkins or at
Mhm.
NIH. It was
Mhm.
just there. It was this other area of research that people were pursuing, and that I shouldn't worry about it.
Mhm.
But of course, as a person, I was becoming, through all of those years, was
Sure.
becoming more sensitive to animal issues. I had become vegetarian and then had become vegan. I had, made the choices not to wear fur or leather and eventually wool, because I learned from organizations like PETA or other animal rights organizations that there was harm associated with those products, with that
Mhm.
food, the food source and it was
Mhm.
clothing source. Um, I had seen with my own eyes the suffering at, certain zoos and
Mhm.
other areas where wild animals are being kept captive. So I'd become like a quiet little animal advocate, in that I just didn't participate in,
Mhm.
you know, factory farming, or, I didn't go to the circus. I wasn't gonna pay anybody else to harm animals. I wasn't gonna harm animals myself, and I wasn't gonna pay somebody else to do it for me.
Mhm.
And in about circa, goodness, 2010,
Mhm.
15 years ago,
Mhm.
um, I adopted a dog.
Mhm.
Her name is Lacey, and she is the Lacey of the social handles we were talking about.
Yeah, yeah.
Beagle mixed dog. Um, I just fell in love with her picture and thought, "Can I have a dog? Like, can I take care of a dog?" And she became my world. And I was working at NIH at the time and working very long hours. Scientists do work hard. As again, we will discuss that I disagree with the use of animals for the purpose of scientific discovery, but scientists work hard. We work long hours, weekends.
Mhm.
And I thought, my goodness, I'm outsourcing this dog. I had like a dog walker, sometimes
Mhm.
to come twice a day. I used to bring her to a very fantastic boarding facility, because we would do imaging. We were working with kids.
Mhm.
So that would have to happen at night or on Saturday. So sometimes we were just there from 6 a.m. on a Friday until noon on a Saturday to collect data from children,
Mhm.
because they have school and their parents are busy. And so I would let her board, and I thought, and I loved her so much. I enjoyed every minute I had with her, but I was like letting somebody else enjoy my dog more
Right.
than I was, because my work was so intense. And so I started to rethink that. That was sort of one adjustment that I was making in my
Mm.
head. But I think that connection with an animal, like that connection that opens you in a way that reading about something or seeing it or even, vicarious um, experiences with other people, other people who tell you how amazing their dog is or squirrels, whatever.
Yeah.
Until you feel it for yourself. And I'm sure I don't have children, but I know that any mother will say, like, you think you know what motherhood is until you do it. And that's a whole different, that connection between parent and child is not something I will ever be able to understand. I think the same thing with having a connection with a non-human animal is something I didn't understand until it happened to me. And I started to just see animals differently and think about it harder. And then instead of being a quiet animal activist, meaning I'm not going to eat meat, I'm not going to eat dairy, get a little more vocal. I decided that this was something I was willing to speak out about and say, hey, I think you should reconsider what you're doing because, and that was new to me. I was never somebody who challenged what other people did. That was not for me any more than what I thought was, what I thought of as a scientist and what I thought of as an advocate have changed substantially over time. And I applied for a job with PETA.
Okay.
But I didn't anticipate that it would be working to get animals out of laboratories. It was I applied for a division at PETA that works with children, making sure that children don't lose that natural empathy. Like kids come into the world and they don't want to eat animals and they don't, but we sort of normalize it for them. And I thought this would be great for me. I have so much experience working with kids. I want to, And at the time, the person who was the head of our science division said, "But you have a PhD and you have all this experience with science and biomedical research. Don't you want to help us, transition the biomedical research community away from animals?" And I thought, what? Because I had never questioned it.
Right.
I had never questioned it. And when that proposition was made to me, I said, "Oh, well, let me look into this before I sign anything. Let me do my own research because I don't think at the time I know, and it's not that I don't think I did not know at the time. One, how many animals were in laboratories. Again, you hear in my experience, you heard about it piecemeal. When you heard about the historic stuff, like back in 1967, they this guy took monkeys away from their mothers, or this other person's. And again, it just wasn't the group of scientists I spent most of my time with. So learning how many animals it was a shock to the system. Learning how harmful it was. How you think you see pictures in a textbook or in a journal at a conference. I mean, right at a conference, if somebody is doing experiments with a monkey or a mouse, they show you a picture of like a mouse sitting in a little petri dish looking all cute, or a picture of a monkey in a tree. There's no tree in the lab. Like that's not a realistic, but that's what they show.
Right.
So the conditions of the laboratories, the harms caused by the procedures, the sheer number of how much animal experimentation was going on that I didn't know about. And for me, now for a lot of people, that would be it, And I have mad respect for people who say we shouldn't be doing harm to other living creatures. That wasn't enough for me. It was for food. It was for for animals used for food, for animals used for clothes, for animals used for entertainment. The harm was enough. But as a member of the scientific community, I think I saw the harms, but I still said, but what? We need to cure cancer. We need to cure Alzheimer's. We need to have this vaccine or this treatment, or we need to understand this disease better. When it's your own community who's being challenged, I think you tend to dig in a little harder. And so for me, it was sort of but they wouldn't be, we certainly wouldn't be doing egregious harm to non-human primates unless we were sure that this research was important. That's not true. People are going to disagree with me on that, but I've seen an insane. No, let me use real words. Insane is dramatic. I've seen many experiments that are currently actively going on that involve extreme harm to animals and that have minimal, if any, scientific value. There are a lot of reasons for that, and I know that there's a we'll probably get to that, but um, realizing how much harm we were doing, how much money we were spending, and how little like tangible benefit a lot of current animal experiments actually have just was, for me, eye-opening and made me willing to try harder to get animals out of laboratories to convince whomever I needed to convince, whether it was the individual researchers, the up-and-coming graduate students, the funding agencies, the universities, that they should rethink this paradigm. And it's tough work. It's not a popular opinion. Things are changing, and we may talk about that there have been some substantial pivots or pre-pivots in terms of how often we're going to be using animals in laboratories. But it's not a popular opinion. I think the general consensus amongst the biomedical research community is scientific knowledge, the pursuit of scientific knowledge, the pursuit of critical information at all costs, at least insofar as animals, that as long as you're not hurting humans in your research, it's okay. And the idea that you can hurt monkeys or rats or Drosophila or mice or bats or voles, I mean, frogs, you name it, they're in a laboratory. And I disagree with that. And it opens me up to be labeled as anti-science. I'm the opposite of anti-science. I'm just anti-harm. I think that scientists are everything to me. These are the brilliant, dedicated, hardworking, goal-oriented, passionate people who generally don't make a lot of money, sacrifice a lot of their time. I just think science can be done without harm. I think science should be done without harm, and then I think then I'll go back to revering it. But that worship, if you will, it's a dangerous word, but the worship I have for science and the scientific community has been tainted by animal experiments and the digging in on some of that.
There are, a bunch of, excuse me, there are a bunch of points that you've made that prompt a series of follow-up questions. I believe, for me anyway, the three biggies are well, the first has to do with this point you make about the kind of the digging in, the recalcitrance of being challenged when you're, a part of the very community that is being criticized. And so I'm curious about how you, from within that community, work to persuade a paradigm shift in, so that's one. Another point that comes up is the going back to your original discussion of people thinking that the ends justify the means, that maybe this is actually true in some cases, but seems, from what you've said, clearly not true in very many cases. How do we navigate what's the standard? It seems to me like one of the standards as well, efficacy. We're not getting any really beneficial results that warrant this sort of treatment to get the result that you claim is beneficial, right? So how do you navigate that? It seems to be of a piece with how you work from within. your discipline to try to convince people that there's another way, a better way.
Mm-hmm.
And then as a lay person, I'm interested in how it seems like rephrase, computer modeling, certain imaging that can be done without non-human animal. Like, we've got so many more tools at our disposal. Why isn't it a no-brainer?
Mm-hmm.
As a layperson who doesn't understand the
Sure.
technicalities,
Yeah.
why isn't it a no-brainer? Like, what's going on maybe in the training that you get? Not
Mm-hmm.
you specifically, right? But that a
Right.
scientist gets.
Right.
Somebody, let's say, like you, as a 21-year-old who would say, "Oh, they're doing this. This must be, you know,
Mm-hmm.
there are these important, wonderful people doing important, wonderful things."
Right.
I'm a naive 21-year-old.
Mm-hmm.
So
Yeah.
I don't know which, if any of those, is something you'd like to pursue.
Sure. Yes, there was a lot in there. So
I know,
so
sorry.
one, within the scientific community, as I mentioned, it's an opposition, especially a hard one, to animal experiments is not a popular take. Um, and I think
Mhm,
that's because one is you are directly challenging the ethics of what your colleagues have chosen to do or
mhm,
are doing in pursuit of their scientific endeavors. And nobody likes that. Nobody likes to be told.
mhm,
We've all been through it where we find out that something we have done in the past or are currently doing is problematic to somebody else, and your defenses go up, right? It's sort of an immediate. Um, and so that has been a challenge. I will say it is. It is. It's not a popular opinion. It goes against the grain of the scientific community, and it can create difficulty with being considered a scientist, right? And there's an interesting documentary for people who are interested in this listening, and for you, called Test Subjects. And several of my colleagues at PETA who do what I do, which is try to get scientists and the biomedical community at large to transition away from animal tests, did do animal experiments for their graduate work and were extremely uncomfortable with it.
mhm,
And when they tried to say so, were basically shunned by even their mentors, the people whose
mm,
labs they were working in. It is
mhm,
not a comfortable thing to do, to
mhm.
challenge the way that science is being conducted, and it's not a popular thing to do.
Can I
That
very quick?
being said, oh, sorry.
No, well, just very, very quickly, can we, at some point, can you say something about what seems to me now an obvious tension
Mm,
between the very nature of scientific endeavor,
mm,
which is always say, "I could be wrong,"
mhm,
and saying something like, "No, no, no, our methods are tried and true, and we're not gonna
mhm.
do anything
Yeah.
differently."
Yes. Well, and that's always been an argument that I try to make when I'm speaking to, funding agencies and
Mm,
universities, which is the scientific community should be the community that falls up the best, right? Like, it is our job to ask questions and fail and then ask new questions. It's our job to adapt to new information. And if the new information is this method doesn't work, then find another method.
mm,
But the truth is, and I think this gets to one of your other questions, it's not as easy to pivot in
mm,
science as we would like. To become a successful scientist studying whatever, whatever your area is, there's a lot of training. Some of it is very formal. You take classes and you go to training sessions, and some of it is hands-on. Like, you're going to be a research assistant in this lab, or and you learn to do the methods that you're learning how to do. And it takes time,
mhm,
and it takes patience, and it takes knowledge, and it's years and
mhm,
years of training. It takes years to be good at performing a stereotaxic surgery on a mouse. It takes years to become good at working with patients. It becomes, or to use this imaging method, or
mm,
it's when people have already invested that kind of
mhm,
time,
mhm,
and they have also built the infrastructure around themselves
mhm,
to do research using methods A, B, and C. It's not a simple pivot.
mm,
It's
mhm.
not like using a pencil versus a pen. It's just
Mm,
not. I
mhm,
wish it was. I wish that science as a whole made it easier for the people doing it to change their trajectory or change their methodology, or, when they are full speed ahead trying to answer question A and then hit a wall, that they can pivot. But unfortunately, that's just not the way that we've built up the scientific community here in the US. A lot of people, from the minute you're in graduate school until the minute you retire, for a lot of people, it's trying to get grant money, it's trying to get papers published, it's trying to present your data at conference, it's trying to get tenure. There's always something that's a little bit secondary to the scientific question itself. It's, did I bring grant money into my institute? Are my graduate students learning properly? Are my courses, am I getting good reviews in my courses? Am I going to have enough papers and enough high profile publications to get tenure? Or am I going to have to, it's a lot of pressure to look successful that doesn't always directly tie with how successful you are in terms of actually answering the question you were trying to answer. Did you get, is at the end of your career as a scientist, how many questions you answered or how many papers you got and how many grants you got? And unfortunately, it's swung a little bit towards the productivity, but some of that productivity might be a little bit empty. And so I think, even though the scientific community, again, I'm speaking in general terms, a lot of people in the scientific community are well aware that animal models have serious limitations. And that's just science, independent of the ethics of it all, is that, humans are not mice, we're not rats, we're not monkeys, we're not any of the other non-human species. And those species differences, or what's sometimes called the species gap, we can't get over that. The attempts have been like, well, let me try to humanize a mouse, or let me try to, insert a gene that is more similar to what humans have. So let me try to induce the symptoms of these diseases in ways that is not how those diseases come to be in humans, but it looks close enough so I can then maybe test whether my treatment's going to work. That species gap, after 100 years, we still don't know how to get over it. And we've tried, and we still haven't gotten over it. And people are aware of that. Like, I think that the entrenchment that years of training and millions of dollars in infrastructure and individual career pressures and is part of why it's difficult to get scientists to move from a method that isn't working even for their individual lab. Like, we're not getting the answers I set out to get.
Right.
But I built my entire laboratory and I've spent my entire life really doing it this way.
Right.
Putting all of my vegan eggs in this vegan basket that I'm going to be able to cure Alzheimer's by studying a rat.
Yeah.
And I haven't yet, but now how am I going to, I don't know anything about brain on a chip or brain organoids. I've never worked with patients. I've never done epidemiological studies. How do I get from a lab that's on this end of campus to this end of campus? It's not that easy. It should be easier. It should be easier, but I don't think it is as easy as we would like. Also think there's some psychology there. And this more recently, like at least since I've been paying attention in the last couple of years, we're hearing more about the trauma that is experienced by people who work in labs. So my focus has always been on the harms that the animals themselves experience, but the people who are asked on a day in and day out basis to do that harm are often troubled. And in some cases, people have admitted to having, what is possibly PTSD because they care for these animals, they feed these animals, they water these animals, and then they kill these animals. And that's a tough thing to do day in and day out. And there's a negative impact on at least a subset of the people who are doing that sort of research. But I know from a woman who did work in a lab, in an animal lab for a while, that she would just tell herself over and over again, I'm going to help somebody someday. Like I'm justifying this to myself. I'm not comfortable decapitating these animals. I'm not comfortable injecting them with chemicals. I'm not comfortable, euthanizing them, but think of all the people with cancer. Think of all the people who have children in the hospital and aren't sure they're going to live. Think of all, and so would tell themselves that over and over and over again. I can't chip away at that. If somebody has spent 30 years doing experiments on animals that they weren't super comfortable with, but that they had told themselves day in and day out there was going to be an end.
Mhm.
Like you say, the end justifies the means.
Mhm.
What if they never get to that end? What if the means have been uncomfortable, the entire, traumatizing in some cases, but the
Mm.
end isn't what they hoped, which is that cure for cancer or that cure for Alzheimer's disease.
Mhm. Mhm.
Um, they can't. Like, and I get it. Like,
Yeah.
I do. I get it. They have blocked that idea that what they're doing could be a lot of harm for very little benefit. They
Right.
cannot accept that for their own sanity,
Sure. Well,
you
and
know?
it makes sense. There's before I had interrupted you when you had mentioned that the documentary, grad students who, they kind of saw themselves in that work and were really uncomfortable, but then there's the pressure from at the individual level from, their PhD supervisor, right?
Absolutely.
Then, of course, there's the whole cultural and socioeconomic infrastructure, right? You've got all
Mhm.
that. But then what you just mentioned reminds me of when you were talking about sort of the psychological component, the following kind of what I might say nail in the coffin overlap of that I'm borrowing from a moral philosopher, um, a bankrupt life, which is to
Mm,
say, if you think of life as if one wants to think of one's life as meaningful,
mhm,
one way to do that would be to engage in these projects of positive value that are at least somewhat successful, this
mhm,
philosopher says. Okay, so if you've been telling yourself for years and years and years that what you're doing must be justified by this goal that you want to achieve, but then the goal doesn't get met,
mhm.
the classification now is, oh, well, your project is bankrupt, your life
Mhm.
is thereby arguably meaningless. That might be too much for someone, right, to bear. So
I think yes, it would
you're
be. I
grappling in your work with how you, I would think, help people navigate that.
Yeah. Yeah, well, and I think the reality is science does happen in baby steps. You have this little
Mhm,
discovery and this little discovery, and then you go back and you try this one again because
mhm,
maybe it wasn't as and so I think that for all scientists, that's those are the the successes, those
mhm,
little successes that they
mhm,
hang on to.
mhm,
And those work, like if that's your career goal is to contribute to the understanding of the brain. You didn't cure any brain related
mhm,
ailments, but you did contribute something to the understanding. Um, is that enough to cause harm to animals to just make a contribution to our understanding?
mhm,
The justification we always hear is the cure, right? Is we're going to help. There are humans suffering with condition X.
mhm,
Therefore, it's justifiable to induce symptoms like condition X in these non-human animals and study it, because then if we study it, even though it's not exactly the same as the disease in humans, and even though these aren't humans, we'll get some little tidbit of
mhm,
information, little snippet of how generally brains work, or how, and that will somehow, amass into enough knowledge that we can. Again, a lot of people say yes. A
mhm,
lot of people say yes. Even if my little study with mice or rats or monkeys didn't cure anybody directly, I answered my question, which was
right,
whatever.
right.
And that gave us a tiny little piece in a very big puzzle. Therefore, it's justifiable. I don't think so.
Mm,
And I also one of the things that frustrates me is when people put those diseases or put those cures or put those new treatments as the reason for what they're doing, when they know very well that what they're doing is contributing a tiny little piece
tiny
to the
yeah.
puzzle. Because for a lot of people, including even me to some extent, but for a lot of people, this discussion, is it okay to inflict harm on non-human animals with the goal of benefiting humans?
Mhm.
For a lot of people, it's gray. It's not. Yes, of
Mhm.
course. Some people absolutely think that humans are above every other species, and that the other animals on this planet are just here for the taking.
Mhm. Mhm.
And then other people, the opposite. Like non-human animals should have all of the same
Mhm.
considerations and rights.
Mhm.
Within the scientific community, I think this is a very gray space. Like, I'm not super okay harming animals, but if there's a good reason, if
Mhm.
we think that hurting 5 mice will help us cure however many people are dying from disease X, we should. And those are fake numbers, of course,
Sure,
because we're
sure, sure.
talking about
Sure.
hundreds of millions of animals each year, and we certainly don't get millions of cures. In fact,
Mhm.
we rarely get them. So, yeah, it's a tough debate.
Uh, so the 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 pressures that you're talking about, are are facilitated by, funding structures. So you also
Mhm.
mentioned that you not only try to, educate, um, individual scientists, maybe at at the lab level as well, or the department level, whatever university level. Um, what about the funding sources? How do you approach them so that, because presumably if you're writing, a grant because you wanted to do research into X, Y, and Z, there are stipulations in the funding proposal process that you'd have to um, satisfy, right? So do you try to get uh, those organizations that fund research to make a stipulation about non-human animal experimentation, or how does that work in
Sure,
general?
yeah. Well, that's the biggest that's I would say, at least in terms of the scientists that I work with at
Mhm.
PETA, is our biggest effort is working to convince the funding agency. So in this case, we're talking, and here in the US, we're talking about the National Institutes of Health, which
Mhm,
is the largest funder of biomedical research in not
mhm,
just in the US, but in the world, but
mhm,
also the Food and Drug Administration, the FDA, the CDC, a lot of the federal agencies that fund a lot of the research that's happening here have historically spent about roughly half of their budget on animal-based experimentation,
mhm,
even though the literature has continued and sort of collectively started to argue that animal-based experimentation is not uh, generating the knowledge that we need about humans. It's not
mhm,
generating the treatments and cures. And we use the word failure, but I am going to be delicate with that word. But what they're not the animal based experiments haven't been translating it into human treatments and cures the way that we had hoped, right?
mhm, mhm,
And that's across any number of research fields, whether you're talking about understanding neurodegenerative disease like Alzheimer's disease and Parkinson's, whether you're talking about infectious disease like trying to generate a vaccine for HIV or other ailments. The data from the animals looks good, but then when, say, a new treatment is applied to humans, it's either not as safe as we'd hoped, which is terrifying, or it's not effective at all. And yet the funding agencies have sort of continue to funnel half of the budget into this sort of this paradigm, this animal-based paradigm.
mhm,
Um, and so a lot of what we had done was, write up reports, say, listen, you're spending this much money trying to create a animal model to study this when clearly the evidence shows that that doesn't work. Please stop. Don't fund this anymore. Fund that kind
mhm,
of a
mhm,
thing. and including something that we call the Research Modernization Now Plan, which outlines all of the research areas where animal models have historically failed, but also has
Ah,
a list of steps that these funding agencies, like the NIH, could do to phase out or phase down animal experiments in a way that was the least disruptive to
hmm.
scientific progress, but also moved it as quickly as possible because, again, we're talking about millions of animals. And this past year, we have seen substantive changes at these federal agencies. The NIH in particular has decided to transition away from animal experiments. They're let me word this carefully so I don't say something that NIH itself would disagree with, but they are looking to prioritize human relevant research using human relevant models. They're looking to reduce the reliance on animal testing. They have established something called Areva, which is an office meant to reduce the reliance on animals and increase the accessibility and the understanding of non-animal models. And we're mostly talking about in vitro tools like organoids and organs
Mhm,
on
mhm.
chips, but also AI. All of the non-invasive tools that are based in human biology and do not rely on animals that we think are what we need to invest in to one, get the answers we need about human disease, but also to get the animals out of labs. And these steps they're I think going to be transformative if we see the NIH follow through with them.
So could you repeat the the paper, the report that you mentioned earlier that PETA put out, and when it put it out, and then Areva is there, presumably there's a website
Oh
through the
yeah,
NRA.
absolutely. I can tell you, yes, absolutely. So PETA's strategy for ending animal experiments is called Research Modernization Now.
Mhm,
Um, and we had an earlier version called the Research Modernization Deal. But after significant progress, we've adapted that to be called the Research Modernization Now Plan.
mhm.
And this is something that we have been promoting to every funding agency, universities, anyone who is a decision maker or policymaker in the world of science. We have presented this plan to, and again, it summarizes all of the failings of animal models, and it makes several recommendations for how the biomedical research community can quickly and seamlessly move away from the failing animal experimentation paradigm and move towards the more human relevant research.
Okay.
Um, the new office at NIH is called, the acronym is AREVA, and what it stands for is the Office of Research, Innovation, Validation, and Application.
Okay.
And the idea is to make sure that we are increasing our investment in non animal research methods, making sure all of these non animal research methods are standardized and valid and accessible. And it's probably one of the biggest steps I've seen at NIH for moving away from animal experiments that haven't worked historically.
Is there any concern, given what's been happening at the federal level with funding organizations like the NIH? Is there worry that this sort of effort, which seems to be gaining traction increasingly, is going to that there will be some deleterious effects, in other words, on it?
You mean in terms of budget cuts, or
Budget cut,
in
yeah,
terms of,
sorry, budget cuts
yeah,
and
yeah,
just priorities.
I think that, yes, I think that there are a lot of changes happening, especially at the National Institutes of Health right now.
Mhm, mhm.
Um, I think I will just say the one that I am 100% on board with is the one that is we are going to stop using animal experiments that don't work. And we're going to make investing in non-animal methods, human relevant methods, the priority. Now, in the grand scheme of it, if there's like a significant budget change, would that be concerned? Yes, but we haven't seen that. Like the NIH's budget itself is looking to hold steady. So if they take some of the money that they had been spending on animal models that have not worked in the past and invest that into things like organoids, organs on chip, AI tools, improving non-invasive imaging, I say all the better. I say all the better. And I honestly, again, I can't predict the future. I can only tell you what I think. So I want to be careful. Because animal, in my opinion, which is, it's an informed opinion, but I could be wrong. But in my informed opinion, we've wasted a lot of money and a lot of time, other resources on the animal experimentation paradigm with hope that it would get us where we needed to go. It hasn't in many, many areas. If we could take that money and invest it into these tools that have a lot of potential, I think we not only will stop harming animals, which would be good, in my opinion, I think we will get answers to questions that have eluded us because we've been using the wrong species in a lot of the research that's been going on. I think we may get the treatments and cures for some of these diseases that are unique to humans and therefore really hard to study in a non-human animal. And I think that it might very well reestablish the scientific community to the public as a worthwhile investment, because I think where a lot of people have lost faith in science has been the lack of tangible benefits for humans. So they see the budgets for, you see, oh, this institute gets $40 billion. This institute gets $20 billion. And if you're at home struggling with an illness that it's hard enough to get the inadequate, pay for the inadequate treatment that they have. You hear on the news, oh, there's a breaking new discovery in Alzheimer's research, and then it turns out it's in mice. And that never ends up coming to your house or coming to your doctor's office or coming to your pharmacy. I think people have, a lot of people, not everybody, but I think a substantive portion of the general population, I think a lot of the policymakers and politicians have lost faith in the scientific community, in part because those benefits haven't arrived. Those human benefits haven't arrived in a timely fashion. So if agencies like the NIH and the FDA and the CDC continue on the trajectory that they seem to be on based on policy shifts and investments they've agreed to make this year, I think that it's going to be a win-win-win. I think that the number of animals being harmed for experiments that aren't useful, down. I think the number of experiments that are going to be useful, up. And then I think that the trust in science is going to go up because I think that the science itself is going to be better.
Oh, that's such a hopeful way to.
I have faith. Again, people say I'm anti-science when I challenge animal experiments. I'm the most pro-science person out there. I really am.
And it actually, if it's okay with you, the question that I would like to end with is the sort of pulls together a number of points that you've made. When we were my wonderful editor Sarah Hoffman had proposed a fit for peer review question for scientists, like what do you whoever you are think about thus and such a subject or a experiment is worthy of publication and worthy of pursuing. So when you think about even setting aside the moral problems with non-human animal experimentation, am I putting your words into your mouth if I say that there are specific features of non-human animal experimentation that renders the results dubious, really not fit for peer review? And is there a way to articulate what that looks like to somebody like me, right? Who's who's sitting at home, like you said a moment ago, maybe saying, "Hey, here's this headline, but it's not coming to fruition in terms of any tangible therapy for thus and
Mhm.
such a condition."
Yeah, yeah. So, yeah, I think to me, for me, the three things that concern me the most when it comes to animal experiments that have been published, so that made it through peer review is one, the species differences, which we talked about,
Mhm,
that are, uh, I don't want to say limitless, but there are a large number of differences between humans and the species that are used in laboratories to represent them. And in scientific publications, they're often overlooked or not really discussed. What you'll see in the introduction of a paper that uses animals, we chose this model because the species is similar to humans in that they A, B, and C, and then that's it. They don't say, of course,
mhm,
dear reader, please keep in mind that they're different from humans. That may come up in the discussion, but often it doesn't.
mhm,
So the tendency for scientific publications describing experiments on animals is to emphasize the similarities and less so the differences. And I
mhm,
think that is a problem. Too. And we didn't talk about this at all yet, so I'll try to do it quickly, is that the laboratory environment itself, so the keeping of an animal in a cage,
mhm,
whether
mhm,
it's a monkey or a mouse or a rat, is taking an animal out of what should be their natural environment and what their entire biology is designed to do
mhm,
and take it away from them, right? Like monkeys are not supposed to live in a cage. Mice are not supposed to live in a cage. A lot of these are intelligent animals. They're social animals. They have adapted over years to live where they're supposed to, which is not in a lab at a university. It's also extraordinarily stressful for
mhm,
them.
mhm.
So their biology is altered by the captivity. And there are things like the lighting scheme, the
Wow.
lights come on and they come off at the same time. The animals eat the same food every day. The animals are at this temperature, which would not be the temperature that they're meant to be. They don't have any of the tools they would use in the wild to cope with stress.
Mhm,
This alters their biology in a way that means that the results you would get from a monkey in a lab are probably going to be different than the results you would get from a monkey in the wild.
mhm,
So they don't even the research from animals in laboratories not only doesn't translate to humans because of the species difference, it doesn't translate to other animals because of the extreme environmental conditions that a laboratory introduces. And you hear all the time, or at least I do, well, the good thing about, testing animals in laboratories is we can control the
Right,
laboratory
right.
environment. We can control when they eat, when the lights come on, and who they enter. I see the point, which is that you're
Sure.
controlling for all of these other variables, but what you're essentially doing is making your finding so specific to your lab that it's not gonna even translate to the lab down the hallway that has, pink paint on the walls instead of
Mhm,
yellow.
mhm,
That's when you hear about a treatment that worked with the 6 people they studied and then it doesn't work for the general population, that's what we're talking about. You're talking
right.
about taking so much out of the variation in the test population that it
Mhm,
has no chance of being robust enough to accommodate the general variation that happens across the population. So I think the data is bad that way, and what's
mm,
worse is
mhm,
that in a lot of scientific publications, they don't describe any of it. They don't
yeah,
tell you what the housing conditions were. Was this monkey raised by a lab worker, or were they raised in a colony? Were they, are they housed with 4 other monkeys or by themselves? Do these mice have access to bedding? What's the temperature? Is it the temperature that their metabolism is used to working with, or is it something less?
mhm,
Are they experiencing cold stress, hot stress? It doesn't get in the method
yeah,
section of the paper. And then you have these, what they call the reproducibility crisis, and it's
mm,
because,
right.
yeah. So the species difference, the laboratory confounds, I think, make a lot of what is published in scientific journals maybe I don't want to use too harsh a word here, but maybe
Problematic.
not worth the paper. Yeah, problematic is the gentlest way to say it.
Yeah.
Um,
Well,
not as good as it might appear.
yeah, and there was, in fact, it came across one of my news feeds, again, headline, right?
Mm,
Something about, what happens when lab mice are out in a field. So they did
mhm,
an experiment with
mhm,
somebody, whoever they are, did an experiment where, they put the lab mice out in a field with sunlight and breezes and whatever else. And look at what we noticed.
mhm.
And
Data's
most
completely different when they
right,
can
right.
actually do what they were meant to do, and they're unfortunately, there's a lot that's almost become a science in and of itself, like a scientific field in and of itself is like, how do we have mice in a laboratory that have the same microbiome as mice in the wild? Like, we've already invested an enormous amount of money trying to improve animal models, right?
Mm,
Because of all of these failings, whether it's the species differences or it's the impact of having them in this unnatural, very sterile, very homogeneous, and not at all what their bodies were meant to be in conditions. And it is things like this. Well, we'll just take the mice out for a walk, or we'll insert this gene, or and I understand the logic behind it, I do, but at the same time, why wouldn't we take all of that energy and all of that money and all of that scientific prowess that the people have and make sure that all of these non-invasive tools that we're talking about, all of these human relevant tools are the best that they can be? Why would I wanna spend more of my taxpayer dollar trying to improve the not so great animal model of schizophrenia when there are people at this other lab who are taking cells, donated from patients with schizophrenia and developing these organoids where you can
mhm,
study
mhm.
how uh, the schizophrenic brain develops or what treatments, how that works. Why wouldn't that be where we put the money? Like, why would we keep investing in? Because we do that. It's human nature, right? It's the sunken cost fallacy. It's the We've already spent billions of dollars trying to make these animal models work. Why would we stop now? Because we need to stop now. But it's a hard argument to sell. That being said, we have been pushing it for years, and as have members of the scientific community directly who know that these
Mhm,
animal models don't
mhm,
work. And we're starting to see a shift. We're seeing NIH make these policy announcements. We're seeing them make these investing their money into these different research tools. Um, yeah, I think we're on the precipice, if you will, of
mm,
what might be a major paradigm shift in biomedical research. And I am not scared at all. For anybody listening, I am not worried. I'm in my 50s. I don't think that I'm going to die earlier because we're finally going to move away from animal-based research. I don't think there's a cure that animal experiments were going to get us that these other tools won't. I really don't.
mm, mhm,
I really don't. I'm not. And that's for I have friends and family like everybody else that
mhm,
get sicknesses like everybody else.
mhm.
I don't think we're going to lose ground. I think we're going to gain ground. I really do.
Which is and if it's the case that these other models are, as versatile and, um effectively make up for what's lacking in the non-human animal models,
Mhm.
including the relevant dissimilarities that aren't mentioned when we're working analogically, right?
Mhm.
All of that is makes for an incredibly, optimistic
Yeah.
future, even if one wants to just set aside the moral question about the moral status of non-human animals, whether or not they have rights, all of that is a really important conversation to have.
Mhm.
But if folks could be convinced on in other terms on this
Yes.
point, then
Mhm.
whatever works.
Whatever
Yeah.
works, if it's the scientific argument that gets you there, if
Yep.
it's the ethical argument that gets you there. The combination of the two cannot be denied, though. We're causing harm and we're not getting benefits. So let's try something new. That's always been my argument, maybe because I work with both scientists
Mhm,
and animal
mhm,
advocates, so
mhm.
I think both of their arguments are valid, but for this one, the science, the animal-based science hasn't gotten us where we need to go, and it's extraordinarily harmful and expensive.
Mm-hmm.
The money argument is another one, right? Like you
Yes,
could
right.
argue
Good
we have
point.
limited research dollars. They might become more limited,
Mm-hmm.
right? Going
Mm-hmm.
forward,
Mm-hmm.
we need to invest in the research that has the most potential to do the most good. And these non-animal tools, these new approach methodologies, you hear lots of terms, human relevant research tools based in human biology. That's what we need to invest in. And we're seeing that. We're seeing at least the start of that I hope will be, the start of a real pivot.
Mm-hmm.
A former NIH director once described, sort of was talking about this topic, like that, that we put a lot of money and energy into animal-based research, and it's not turning out as useful as we thought. And he said, but it's like turning the Titanic. That's what he said, because it's full steam ahead, and it's not that easy to turn a ship that big as quickly as you need to. And that's I mean, it was the perfect way to describe what trying to change hundreds of billions of dollars and decades of scientists and institutes and laboratories all heading in one direction, using all these tools, and say, no, stop.
Yeah.
It's but we're doing it. Like the engines on animal experiments are being shut down, and the wheel is starting to turn. And I what I hope is that people, especially the young scientists, who are at that path in the road. Am I going to work in this lab where they're studying this particular, answering this particular question with animals, or am I going to go and get my training in this lab where they're not? Not. Even if you're comfortable with it ethically, though, don't be. But even if you're comfortable with it ethically, the money's going to dry up, right? Because we're moving the other direction. And I think if the young scientists, the up-and-comers, the new scientists, invest their time and energy getting trained in these non-animal tools, I think that's going to make as big a difference as the NIH changing its funding priorities. I really do.
Okay.
But they need to do it. And I hope other scientists do, who are stuck in an animal model and have long given up hope that they were going to answer the question they wanted to answer when they were 19. Consider, please, give up the run. Like there's going to be tools available. Reach out to me. I'll help you find it. I'll help you find the funding. That's what I do.
Well, I hope that we'll have an opportunity to chat again, so that we can follow up. Like, hey,
yes, the progress report. Yeah,
right. Yes. How are things going? Where are we with the progress with NIH, and how many folks have reached out to you to get some support? So I hope that we will have the opportunity to chat again.
Yeah, absolutely.
Oh, well, thank you so much for taking your valuable time and sharing your story, your expertise. It's all appreciated. Thank you.
Of course. No, I'm happy to do it. And if you have follow-up questions or you need links to anything, just let me know.
Okay, most definitely. Well, thank you again, and please join me next time on The Life of Her Mind. Meanwhile, please visit labroots.com for trending news, webinars, virtual events, and more. Dr. Katherine Roe, thank you, and I hope that we get to see you again.
My pleasure. Thank you so much.